All right, ladies and gentlemen. Sorry you were absent on the day we went over the lab explanation, but I'm going to give it to you now. So you need to open two things, ladies and gentlemen. You need to open the alternate assignment that I put in for your lab, and you need to open the graphing to find density spreadsheet that I put in for your lab. I've replaced the ones that were in your original lab with these, so these should be what you have. First thing you need to do, ladies and gentlemen, is you need to make observations of these samples based on the pictures here. I know that's not the easiest thing to do, but you need to make 3 observations of them. When you are done with that, ladies and gentlemen, you are going to insert a data table. The data table is already done for you. So if you go to the Google Sheet that I gave you with the lab, you will find this Google Sheet data table for you. You are going to highlight this data table. You are going to press Control C, or however you do, copy. Then you will come back into the lab document. Get your cursor blinking right underneath where it says 1 point and hit Control V to paste the table. And yes, you want to link to spreadsheet, paste it, and now you have your data table in your lab for yourself. Do not worry about this part in white here. Since you did not do the lab, I'm not going to hold that against you. Everything you need is in these 2 columns. We're now going to go down to where we have to insert our graph. Now we need to do a little bit of work on our graph first. So let's go back into Google Sheets and let's go to the graph part. Now, in here, ladies and gentlemen, you are going to have to change your titles on your X and your Y axis. I already have them set for you in this video, but you are going to have to change them in your actual lab, in the actual Google Sheet. So to change them, you go Edit, Customize, and then you do Chart and Axis Titles. Horizontal axis, you will highlight what is written there, which should have been Axis Title and Unit, and you are going to change that to read volume, which is what was on the x-axis, and the unit is milliliters. Close the parentheses. Go to your horizontal axis, and again it will read axis, title, and unit, and you are going to change that to read mass and the unit of grams. One more thing that you have to change, ladies and gentlemen, is you have to change the chart title, and you're changing that to volume versus mass, just as we would have done in the activity. Oops, sorry, I accidentally did the subtitle. I'm going to change that to the title, highlight that, and change it to volume versus mass. Now, the only other thing you need to do to your graph is make this line. I will already have that set for you, ladies and gentlemen. You do not need to worry about it. This blue line here is what we call a trend line. The way I got it in is I hit Series. Again, I'm under Customize. I hit Series, and I go down to here, and I added a trend line. I make it disappear. I make it appear. And I also want the equation, because that is the important part of this, ladies and gentlemen, is the equation. So I now have that written there. I have that good to go, ladies and gentlemen. I am done with my graph. Now, to put my graph into the lab, the document, I go into the document. I get my cursor right underneath where it says 4 points. I come up to my ribbon at the top where it says Insert, Chart from Sheets. Click on it. For those who missed that, Insert, Chart from Sheets. Click on the graph in the upper left-hand corner. That should be the most recent graph you are working with. Hit Insert. You have to select this graph. Once you have the box highlighted like it is now, you can hit the Import button, and it will import the graph for you. Those were the 2 things that you needed to get done in the lab. Now, ladies and gentlemen, you are ready to answer your questions and do your calculations. So let's begin with your calculations here. The calculation that you're going to do is density is equal to mass divided by volume. Now, you are going to use the numbers that are in this table. Here is your mass. Here is your volume. You are going to take mass divided by volume for each of these. The smallest rod, the third smallest, the second smallest, and the largest. So that is these four boxes right here. Smallest, third largest, second smallest, largest sample. You are going to take and you are going to do mass divided by volume for each of these four. Now if we go back and look at our numbers here, ladies and gentlemen, all of our masses are to 5 sig figs. But these two, the two smallest objects, the volumes are only to 2 sig figs. So when you divide these numbers, your density can only be to 2 sig figs. When we get into the two larger objects, their volume is over 10 milliliters, so that gives us 3 sig figs here. So when we divide 5 sig figs by 3, our answer can only be in 3 sig figs. So going down to this table, these two boxes here should be reported to 2 sig figs. These two boxes here should be reported to 3 sig figs. Then you are going to find the average of these four densities. Average is found by adding up those four numbers all together and getting a total. Dividing that total by 4. Now, just as a point of reference, ladies and gentlemen, the average should always be between the highest and the lowest value. Be between the highest and lowest value. So, when you get this number, check your numbers up above. Which one is the highest? Which one is the lowest? This average should be to 2 sig figs like these two measurements were. Now this is one of the ways that you are finding density in this lab. You're taking the average of the 4 samples to find their density. The other way we find density, ladies and gentlemen, is right up here. And it is this formula up here. Okay, sorry, didn't want to click on that. This formula here of 2.31x plus negative 0.553. That is the formula for the slope of a line. Y equals mx plus b. Now the only part of that I am concerned with is the slope, 2.31. Slope is equal to rise over run, ladies and gentlemen. That's what slope is equal to. Now, in this lab, the rise is mass. The run is volume. Since we get a straight line that's going up, that represents a constant direct relationship. The direct relationship says as mass increases, volume increases. The straight line says that the slope of this line does not change. It is always 2.31. And that slope represents mass over volume, which is density. So this number, this 2.31 right here, up at the top, is the density, ladies and gentlemen, is the density of that substance. So that is the second way that you will find density. You will just look at that number there. That number, 2.31, is the density. So you found density that way, and you found density by calculating an average of the 4 samples. Now, let's take a look at the questions. I just answered these questions for you. What are the 2 ways we determine the density of objects in this lab activity? We just gave you those. We also just explained to you how to find the density on the graph. You just need to tell me how we did it. So those 2 questions are taken care of. Tell the difference between qualitative observation of density, tell the difference between the observation of density and color. Well, think about what density gives you and then what kind of observation is it, qualitative or quantitative? What kind of observation is color, qualitative or quantitative? And then tell me which one would be better used to identify the substance and why. Now, to be honest, ladies and gentlemen, I will accept either one, density or color, as the better way to identify the substance. You get your points because of the and why. You need to explain to me why density is a better way or why color is a better way. There are lots of reasons you can give me, but they need to be scientifically sound. Don't tell me color is a better way because I think colors are pretty and I like looking at colors. You need to explain why color would be a good way to identify the substance and why density would. So next, ladies and gentlemen, we get to our conclusion. So based on the table below and the evidence from the lab, tell what kind of material your group used in this experiment. So here is the table below. Here are the different materials: maple, polypropylene, polystyrene, polyamide, acrylic, polyurethane. These are the different substances. And the reason we asked you to look at the color was so that you could tell what the substance would be. So for your sample, ladies and gentlemen, it was this one right here because it was white. So in your conclusion, you need to tell me what the type of material was. Then you need to use data to support your decision. So you want to tell me something like, we found that the material is made out of this. And using density, in our lab, we found that our density was, you could either give me the number that you got here for an average, or you could give me the number you got here for the graph of the line. So again, you're telling me that you found that the density that you found in the lab was this number. Well, the known density for this substance was right here, ladies and gentlemen. So you tell me that in your conclusion. We believe it was this material because we found the density to be this number, which is close to the known density, the accepted value, the target value shown in this table. And that is how you write your conclusion, ladies and gentlemen. Now you do have one more thing to do, and that is this calculation right here to say how well you did your lab. To do this, ladies and gentlemen, what you are going to do is you are going to actually click into these formulas and you're going to take out these words and you are going to replace them with numbers, and then you are going to tell me equals a certain percentage. Okay? So for both of these, you are going to do equals a certain percentage. Now, the way we calculate that number, ladies and gentlemen, is this is your target. This is your accepted value. So everywhere in here where it says accepted value, I'm going to replace it with that number. I'm going to click it. I'm going to highlight the words. I'm going to replace it with that accepted value. Now, you do not have to worry about units because your units are already set as a percentage. So you only have two numbers left to enter and then do the calculation. This experimental value for your calculation by density, that is the number, ladies and gentlemen, that you have right here in this box. Whatever this number is here, you put it right here where it says experimental value. Now you do this calculation, get the number that comes out of your calculator into 2 sig figs, you put it right there. Now, I don't care if it's a positive or negative percentage, that doesn't matter, but that's where you get that number. For the one at the top, to calculate the slope, density by slope, that comes from this number right up here in this formula. That is the number that you are going to use. You plug that into this formula right here where it says experimental value. Take that out, put that number in, get your answer to 2 sig figs again. Once you have all this completed, ladies and gentlemen, that is it. You are done with your lab. You can turn it in. You have 2 days to get it finished after you come back to school. So that means by Thursday of this week, I should get this lab from you, ladies and gentlemen. If you have any questions, you need to come and see me during advisory or ask me after class. I'm here after school for tutoring as well. So that concludes this video. If you missed something, go back, rewind, watch it again. But everything you need to complete the lab is here. Thank you, ladies and gentlemen. Have a good day, and remember to get the lab